Welcome, everyone. We're going to give just a couple more minutes for more people to log on. Okay, I think we'll go ahead and get started. Welcome, everyone. This is Randy Sandona. I'm the Executive Director of the Critical Infrastructure Resilience Institute, and I'd like to welcome you to this installation of our ITI CIRI webinar series. We're delighted to welcome today Aaron Clark-Ginsberg, who is with the RAND Corporation. He will be speaking today on regulating complex critical infrastructure risks, the evidence from the electric grid cybersecurity standards. Since we're here at CIRI are focused on all of the critical infrastructure sectors, we recognize that some sectors are more heavily regulated than others, yet nevertheless all sectors are impacted in one way or another by policy and regulation. And far too often, as we all know, this well-intended policy and or regulation, at least when it meets and interacts with the real world, actually triggers unintended negative consequences. And I think Dr. Ginsberg's research has borne that out. And informing policy and regulation is one of the four strategic research thrust areas here. And so Dr. Ginsberg's research has been is particularly relevant to us. He and his principal investigator, Dr. Rebecca Slayton, conducted research that really hit the bullseye with respect to our focus area, as they focused on the North American Electric Reliability Corporation's Critical Infrastructure Protection Standards. And Aaron is here today to review that research and share with us some of its findings. In particular, Aaron will share a few recommendations from lessons learned in that research that could help regulators reduce cybersecurity risks while avoiding potential negative consequences. And we really look forward to hearing his talk. Dr. Ginsberg is a social scientist, as I said, currently at RAND Corporation, where he's doing disaster-related research for the Department of Homeland Security, Centers for Disease Control, and the Air Force. While he was at CIRI, Dr. Clark-Ginsberg was a postdoctoral scholar at Stanford University. He completed his graduate research studies at University College Dublin in humanitarian action, and his research has taken him to 10 countries in Africa, Asia, and the Caribbean, where he studied disaster risk reduction and resilience building activities. We welcome him here today, and Aaron, I'll turn it over to you. And if I would very quickly, if everyone would please mute their connections while the talk is underway, I'd appreciate that. Thank you very much. Go ahead, Aaron.
Thanks, Randy, and thanks for inviting me to this, and thank you all for taking the time to listen to me talk. So the title of my presentation is Regulating Complex Systems, Evidence from the Electric Grid Cybersecurity Standards. And I'm here to tell you about the impact of what's called the NERC-CIP standards, the North American Electric Reliability Organization's Critical Infrastructure Protection Standards. And these are the standards for the U.S. electric grid and the electric grid of Canada. As Randy mentioned, it's based on a CIRI-funded study that I conducted with Dr. Rebecca Slayton from 2016 to 2017. And it really represents some of the first empirical research on the impact of regulations for cybersecurity of a critical infrastructure. The research question we were working to answer is, how have the NERC-CIP standards shaped the way risks are managed in the electric grid? So, our study itself, it's on regulations, and I mean, I think this is a little bit of an unpopular topic. I mean, when you think about policymakers, oftentimes it's, you look away from regulations, including those for risk mitigation, in favor of more kind of lightweight voluntary agreements or public-private partnerships or other measures. Regulations are almost the mechanism of last resort for mitigating risk. And I mean, this is also true for cybersecurity kind of across the board in general. But I mean, what we've found is, by and large, they've been crucial for managing the cybersecurity risks for the electric grid, and they've had a lot of positive effects on the grid itself. I mean, along with those positive effects, as Randy's alluded to, they've had some sort of negative effects that, in some cases have reduced cybersecurity and reduced the reliability of the grid. But they've also had some positive benefits. So I'm gonna walk through, what we found in our study. I'll start out with a little bit more background to the study, talk about the research question, our design, and then dive into the findings before concluding. So the story of the NERC-CIP standards really starts with the 2003 Northeast blackout, which occurred one evening on August 14th. The blackout, it was one of the biggest in the world and the largest in North America. It left 55 million people across 8 U.S. states and then the province of Ontario without power. And, it was massively expensive too. It cost about $10 billion in economic damage. Now, the blackout kind of showed the importance of regulations. When the blackout occurred, the electric sector was governed by a set of voluntary reliability standards developed by the North American Electric Reliability Corporation, or NERC, which is a nonprofit created and controlled by utilities focused on ensuring the reliability of the bulk power system in North America. So these were voluntary regulations in place. Now, in a review of the blackout, a government task force, they found that there were extensive violations and that they contributed directly to the blackout itself. So these voluntary regulations or standards, they weren't being followed, they were being violated. In addition, the blackout was partly attributed to a software bug found in a utility's control room. Now, the task force viewed this software failure as evidence that a deliberate cyber attack could have significant impact on the power grid. So it said, there's terrorists and other malicious actors who have the capacity to conduct a malicious cyber attack with potential to disrupt the energy infrastructure. Using that software failure as an example. And I mean, this was also kind of a post 9/11 environment where critical infrastructure protection and cybersecurity was kind of on the fore of a lot of policy discussion in the U.S. And the task force's concerns over cybersecurity, they seem to appear pretty valid. If you look at the history of the grid, since the 1950s, industrial control systems, these are the computers used to control and remotely manipulate industrial machinery, they've been integrated into the electric grid and on an increasing frequency. And they're being used both for efficiency because you could get power to the right places at a lower cost, along with reliability. So you could track information and help kind of catch problems as they emerged. These computers, these industrial control systems were reducing the chances of blackouts and other potential failures. But they're also creating risks. So, hackers could potentially disrupt some of these control centers and by targeting the computers that were kind of scattered across the grid. So from this, Congress, recognizing that the integration of all of these industrial control systems represented a severe public risk, in 2005 enacted the Energy Policy Act, which included provisions to make reliability standards, including cybersecurity standards, mandatory and enforceable across the U.S. So instead of being voluntary, they moved towards being enforceable. The NERC CIP standards were kind of birthed from this process. The standards, they're developed by industry through NERC, that organization that represents the different utilities. And then they have oversight from the Federal Energy Regulatory Commission, or FERC. They are mandatory. You can be fined upwards of $1 million a day per violation. I think it was this February, the largest fine ever was given to a utility for, it was 127 violations in total, and the fine totaled $10 million. So the fines can be relatively large. And the standards themselves, they're constantly evolving. They're currently in their 6th iteration, and more changes are coming. They're kind of living standards and evolving documents. And they tend to be evolving towards the larger, towards bigger. The standards themselves, they cover a lot of different elements that can be considered the basic elements of what we know works to manage risk. At the time of this research, there were 10 standards with 32 requirements. So it's kind of an extensive number of standards. They include the identification of high, medium, and low impact systems. So systems that, if they fail, they can have a little bit of an impact to a large impact, and then you kind of tailor the provisions and the mitigation strategies based on that level of impact. Some of the interventions, they include cyber and physical protections, segmenting systems, training staff, implementing response and recovery plans, and then broader kind of governance and planning arrangements. So it's a fairly comprehensive set of standards that covers quite a bit. And the standards themselves, they created quite a few kind of policy questions. So in Michael Asante, he's been quoted as saying, that they've had a fairly positive effect on the bulk electric system. He said, we believe that the NERC CIP efforts have improved and will continue to improve the reliability and security of the bulk power system. It's great. On the other hand, Tim Roxy, who's also at NERC, he stated, we have a culture of compliance when we should really have a culture of security. So making the argument that, we're focused on compliance and the standards aren't really focusing a whole lot, leading to much of a focus on security. CRS, Congressional Research Service, they've actually questioned the standard development and setting process, this sort of industry-driven process, and alluded to the fact that it may be a potential conflict of interest, kind of a regulatory capture argument. And then, you have stuff like the President's Commission on National Cybersecurity saying that policymakers have generally not looked very favorably on regulations as a solution to cybersecurity. Cybersecurity, it evolves very quickly. It's kind of this dispersed risk. Regulations change slowly. It's a very kind of concentrated approach to governing risk. So in other words, the standards themselves, there's a lot of questions on whether they work and how they work from a policy perspective. There's also broader questions about the role of regulations in society for mitigating risk. In the field of public administration, there's Ariane Boyne and Martin Lodge have described how there really isn't much scholarly research and attention devoted to looking at how regulations can be used to mitigate risk. Similarly, the organizational sociologist Charles Perrow, who's done a lot of work on risk in complex systems, he's raised similar concerns, saying, the field of sociology in many ways has abandoned the study of regulations and risk and needs to have kind of greater attention played to this field. So there's certain policy questions that we have about the NERC-CIP standards, and then there's broader kind of questions about what's the role of risk in society and for governing complex systems. This led us to the research question of how have the NERC-CIP standards shaped the way risks are managed in the electric grid. So our study, it's very much focused on the electric grid as a whole, not just the role of the standards for one utility or one subset of the grid, and it's focused on these NERC-CIP standards. And the utility, it's one of the first studies of how critical infrastructure cybersecurity standards function, and it offers a new way, or we've found a new way of thinking about regulatory capture and expertise. We did some digging into the question of, is this standard setting process, does it lend itself to regulatory capture? What is regulatory capture? Is this occurring? And we found that a lot of the disagreements that are often seen in the standard setting process have less to do with issues of regulatory capture and more to do with conflicting views of expertise and ideas of whose expertise counts that we'll get into in a bit later. Research design, it's a very kind of complicated subject with little research done. So we've taken a kind of qualitative and iterative approach focused on producing both new knowledge and improving practice. The data that we've collected, we've relied pretty heavily on interviews with over 70 stakeholders within the government and private sector stakeholders and regulators of all sorts, and then observational research coupled with a lot of documentary data and analysis. And then we've produced several different outputs, and this includes conference presentations and academic articles, but we've also produced more kind of applied articles and then government briefings as well. So let's talk about the findings. Our respondents described regulations as a dynamic and emergent regime involving interactions between many players. So there was a lot of people involved in shaping these regulations and kind of developing these regulations and using these regulations. And these interactions, they shape and are shaped by three related aspects of regulation, three important components. These are incentives, how regulations affect behavior, scope, what the regulations cover, and adaptation. So this is how quickly regulations and regulated industries change. And these aspects, they emerge, incentive, scope, and adaptation, they emerge from the interactions between the formal regulations, so the NERC-CIP standards, and complex socio-technical systems. This is all of the components that make up the electric grid, the people, the technology, the other regulatory and governance processes. So these three components, they really influence the effectiveness of the standard. So incentive, scope, and adaptation are what kind of influence the effectiveness of the standards. And I'll talk about each of these in more detail, starting with incentives. So one of the first kind of major findings that we've identified is that the standards, they haven't been sufficient to eliminate all vulnerabilities. The electric sector, it's incredibly complex. There's a mix of technologies and social processes. There's thousands of different utilities. Each one has its own kind of organizational structure. Over 400,000 miles of transmission lines, 6,000 generation facilities, and then there's numerous regulations and regulatory bodies. The NERC-CIP standards and NERC being just one form of regulation and regulatory body. So it's this very, very complex system, and it means that basically accidents can happen. As one of our respondents told us, Murphy regularly finds its way into the utility business. Things like perfect storms happen all the time. These unknown unknowns are realized kind of on a semi-regular basis. And the regulations can't eliminate that from happening. In addition, the standards, they aren't designed to be, I guess, the gold standard in cybersecurity. These are kind of baseline or minimum regulations. Our respondents describe them as, a start, a baseline, or a floor. They couldn't, for instance, and they aren't designed to provide protection from a well-resourced actor like a nation state, which, it could have the capacity to overwhelm the resources of a utility. And I think this is very well demonstrated in the technical feasibility exemptions for legacy industrial control systems. So there's certain industrial control systems that, they don't have high levels of cybersecurity. And instead of removing those legacy systems, they're exempt from the NERC-CIP standards. So you weren't required to remove and replace, they're left in place. So that's kind of an example of the standards as a baseline or a floor. So while they haven't eliminated all vulnerabilities, they've had very important positive effects. First, the standards increased attention to security and resources for security. So with the standards, a lot of our respondents described how there was a lot more executive attention focused on cybersecurity. As one said, faced with the possibility of a $1 million per dollar a day violation, eyes get opened and you get a lot of attention. And in his organization, that attention translated into, approximate tripling of staffing for control centers. And his experience of increase in executive level attention, increases in resources, and changes in budgets, that was something that we heard broadly and widely. That standards represented this sort of forcing function of increasing attention. And along with an increase in attention, it also resulted in changes in operations. So you have not just more employees focused on cybersecurity, but different procedures in place to mitigate cybersecurity risks. So networks were segmented, staff were trained, incident response procedures were set up. All of these activities were enacted in response to the standards. One of the problems, however, is that a lot of this attention goes to compliance activities rather than kind of the basic mission of security. So we heard, anywhere from 30 to 70% of budgets devoted for security went to compliance, went to proving that you were in compliance with the standards, or doing other activities to ensure compliance rather than security. And sometimes this meant that security experts were removed from their security details to focus on compliance. So that, it was a very kind of compliant heavy focus and regime. And the reason for this is that the standards themselves created certain kind of negative incentives that hindered security in many ways. So one example, some organizations were penalized for establishing policies that went beyond NERC-CIP requirements and then failing to uphold them perfectly. One example we heard is patching. The NERC-CIP standards require organizations to review patches, security software updates, at least every 35 days. Some organizations had more stringent policies. If they failed to follow those policies, those more stringent policies, they could be dinged. They could be fined or found out of compliance, even if they were still well within the 35-day mark. So this meant that, as one of our respondents said, that a lot of facilities just got gun shy. They moved towards whatever the NERC-CIP standards were saying. Other organizations, they ended up reducing security and reliability to avoid compliance paperwork burdens that could be also extensive. An example that we have is Blackstart capabilities. So Blackstart capabilities, they're small generators used to get generation facilities up and running after a blackout. Version 1 of the standards classified these Blackstart capabilities as critical and subject to regulations. In response to this, so these Blackstart facilities, they're fairly, they can be fairly small. In response to this, as many as 25% of organizations chose to remove those capabilities rather than maintain their compliance burden. So, this has a pretty big impact on the recovery, the ability of the electric grid to recover from something. This is both a cyber incident or a cyber attack or a natural disaster, since Blackstarts are necessary to get the grid up and running. So for some organizations with good security practices, NERC-CIP lowered levels of security because they faced this burden of compliance and perverse incentives. And for organizations with poor security, NERC-CIP raised the levels of security because they were forced to implement, these sort of basic practices to maintain security. So in other words, NERC-CIP, it has a leveling effect across different organizations with different levels of security. And this is because NERC-CIP, it creates incentives around compliance, not security. Organizations move towards whatever this compliance ideal is, but because compliance isn't directly aligned with security, they're moving towards that compliance ideal rather than the security ideal. A recommendation that we have for this is NERC and FERC should revise the standards and auditing procedures to eliminate perverse incentives. And there's two kind of specific sub-recommendations for this. One of them is, you should eliminate the requirements for an entity to follow their own policies directly. Instead, you should focus on the NERC-CIP standards and say that, you have to maintain a minimum level of compliance with the standards. If your standards go above and beyond, that's fine, that's good. You don't need to follow them directly as long as you maintain whatever that minimum level of compliance. Another way around this could be lowering the inspection priority for utilities implementing practices that go above and beyond what the regulations demand. So, if you have policies and in the past, you've proven that you've been implementing security to a high level, you could exchange compliance monitoring for, a greater focus on security. So it's, being a little bit more relaxed with your level of auditing for those organizations that are perceived as having high security. So we've talked about incentives, and now we're going to move on to scope, what the standards cover. And what we found is that the standards, they covered many critical elements of the bulk electric system of the electric grid. But then there's key portions that the standards didn't cover and that were out of scope. Distribution is one of them. Distribution is out of the scope of the standards because it's a state issue jurisdictionally. The standards and the federal government's oversight is limited to the bulk electric system, so whatever crosses state lines and or has an impact across state lines. And this is large-scale generation and transmission. So distribution, it has less of a systemic kind of impact on the electric grid, but I mean, compromising a distribution system could leave a city without power. However, I mean, it is a state issue, and it's up to the public utility commissions to regulate, and their approaches to critical infrastructure cybersecurity are quite diverse, and fairly limited from what we've seen. And from what we've seen, I mean, there isn't a lot of research on distribution at the state level. We know that there's more kind of interest among public utility commissions, but we don't actually know what they're doing or how well they're doing. So distribution is an area that was out of scope. I mean, another area out of scope is other infrastructures. One of our respondents described how the gas system isn't NERC-CIP compliant, and the supply chain isn't NERC-CIP compliant, and transport isn't NERC-CIP compliant. Because none of them are NERC jurisdictional. These other infrastructures are the jurisdictions of other critical infrastructure regulatory bodies. NERC doesn't have jurisdiction over that. The problem is that the electric sector, it's not an island unto itself, but it's rather dependent on these other infrastructures for its processes and to function. And if these infrastructures were compromised, there could be a potential for a cascade to then create large-scale blackouts. And there is, and we heard relatively little evidence of coordination for electric grid between NERC, FERC, public utility commissions, other stakeholders and other infrastructures. So those sorts of institutional linkages, we were not hearing much about, and the critical infrastructure protection was by and large kind of siloed and not aligned for addressing infrastructural interdependencies. I mean, this led one respondent to describe the standards like the Maginot Line. I don't know if any of you know World War II history, but the Maginot Line is the line that France enacted between the wars to protect itself from German invasion. And the line itself, it was a very strong line of protection where it was located, but it could be bypassed, and that's exactly what Germany did during the war. It bypassed the line by invading France through Belgium. And the electric grid, it can be thought about like the Maginot Line because it's highly coupled both with distribution. The local electric system is coupled with distribution as kind of the endpoint delivery service, and then with other infrastructure. So and that high coupling means that it's very dependent on these infrastructures, and it means that the regulations that just focus on that one component miss out on a lot of the security threats or potential security threats. So the policy recommendation that we have is, this isn't an issue that NERC or FERC can necessarily address on its own. This is more of an issue for potentially DHS and public utility commissions. The policy recommendation is DHS and public utility commissions should develop mechanisms for facilitating coordination between different infrastructures and regulatory sectors across jurisdictional levels to improve electric grid security. So it's not about expanding NERC to try and encompass other infrastructure. It's about strengthening those other infrastructure by better coordination and by better processes. We're going to now look a little bit more about adaptiveness. And I guess kind of in contrast to what many think when they think about regulation, instead of stymieing progress or hindering adaptation, what we saw was that the standards themselves, they really facilitated a lot of adaptation. They created both a new industry and the development of new forms of competency and expertise. So how do they do this? Well, first, the standards, they're expensive. Implementing cybersecurity and changing systems requires a lot of financial resources and human resources. In response to these standards, a collection of vendors and other companies emerged to service, the needs of utilities. So you have, consultancy companies like Alien Vault, which provide software for NERC compliance, or organizations like Dragos that, provide cybersecurity expertise specific to industrial control systems. So you have this industry that emerges because of the finances behind the regulatory requirements. Along with that industry, expertise also emerges. If you go back to the early days before the standards, people were not really thinking about industrial control system cybersecurity. Cybersecurity instead was, something that maybe financial systems and business systems, front of the house type activities were focused on. It wasn't something being considered at the industrial level. But, the standards themselves, drafting the standards requires bringing together the engineers, the operational technology engineers with the IT folks, and working together and thinking together about, how do you secure an industrial system, and a technological system. So during the standard drafting process, there was a lot of working together between, these two kind of previously distinct fields, and from it, a new form of expertise emerged. It's the operational technology cybersecurity expert. The person who is focused on industrial systems and cybersecurity. And what's fascinating is that this really happened endogenously. So because of the standards themselves generated or assisted in generating this new form of expertise. So it came within, which I think is kind of neat, and shows another additional kind of positive benefit of the standards. This sort of expertise and the bringing together of the OT and the engineer and then the cybersecurity expert, it wasn't necessarily harmonious though. Working together wasn't smooth. The engineers had different views on what the threats were compared to the IT people. The engineers, they're a lot more concerned with reliability issues related to natural hazards or maintenance problems, whereas the IT people were a lot more concerned with this sort of looming cyber threat. And you can, if you review the development of the standards, you can see that there was a lot of conflict between IT and OT, over what should be done and how cybersecurity should be regulated due to reliability. And this sort of conflict, I mean, in some ways it was interpreted as regulatory capture. People were thinking, oh, they want lower cybersecurity regulations because they're trying to avoid compliance and because they're trying to avoid spending money. That was maybe part of it, but a big part of it was because there was this battle going on between the reliability side and the engineering side and the cybersecurity side. And the standards themselves, I mean, they are adaptive. Adaptiveness is built into the standards. It's this kind of continual process of revising and updating the standards in response to changing threats and changing technology environments. So you have this sort of constant process of adaptation and revision. And you can see the results. So a lot of people described how the most recent version of the standards is a lot better than the first version. And if you look objectively, the requirements are a lot more stringent and a lot more advanced. If you talk to people, they say that the regulatory mechanisms and auditing practices are a lot better. So that there's been this good evolution since 2005 and the first kind of version of the standards. However, the adaptation process is slow. The standard drafting process is pretty slow. It takes 36 months on average to develop standards, which, I mean, that's pretty fast for regulations, but it still is much slower than the rate of change and specifically technological change that the industry is going through. And this is a lot of people would talk about this, how technology is changing quickly and the laws are lagging behind technology. And this both creates security problems. The gap between technology and regulations, it can lead to that gap can be filled by security threats. Or it can just hamper innovation. Sometimes utilities are reticent to, they'd be reticent to adapt to new technology for fear that whatever the next iteration of the standards would be, would conflict with whatever technology they have, and they would lose what is a very large capital investment. So that adaptation, could hinder both security and innovation. And by way of recommendation, our recommendation is to facilitate adaptation. NERC and FERC should work to establish standardized values and expertise related to cybersecurity. If you remember the last slide, I mentioned that there is conflict between the engineers and the cybersecurity people. There's also conflict between the engineers and the cybersecurity people and the environmentalists, and between the efficiency people who want low costs there's all of these different views on where cybersecurity kind of ranks compared to other issues that the electric grid is facing, and how much value to put on it. Those conflicts can, lead to crossed wires, and they can slow down the standard drafting process and, cause what is a relatively fast process to be a little bit slower. One way of speeding up that process would be to try and start to get people on the same page and thinking in the same way. This is happening a little bit with the development of a core group of expertise, but it could be sped up. You can bring together a wider group of people to talk more about what the role of cybersecurity is and what its place is in the electric grid. The grid itself, it's a super complex system, and the standards have to cover a lot of different practices. So I don't think that this is a silver bullet. It still is going to be a long process, but it could speed it up a little bit more. I know we're kind of getting close to the end, so just to recap and conclude, what we found in our study is that the NERC-CIP standards, they did a lot to improve cybersecurity, but there were still challenges related to adaptiveness, incentives, and scope. There were also opportunities that arose because of adaptiveness, scope, and incentives. You have the birth of a new industry. So it's, these regulations, they can help to mitigate risk, but they can create positive and negative emergent outcomes. Positive being the new things, the new amounts of attention, and then negative being kind of the limited scope of the regulations and this sort of compliance type regime. It seems like these emergent outcomes, they're critical to what the standards do, and are in some ways, more profound than whatever the standards directly set out to do themselves. Second, the standards themselves, they aren't just technological. They're focused on a technological process, but the way that they work is dependent on organizational structures, organizational values, other things beyond technology themselves. When you're thinking about designing regulations to mitigate critical infrastructure risk, or just working to mitigate risk in general, it's not just about the technologies in place that you have for risk mitigation, but it's about the organizational dynamics and institutional processes. So you should design regulations to match that. And then third, it's a call for more research. What we found was that the standards, they had an impact, they had a positive impact, there were some negative parts, but there is this incredible complexity about what the standards actually did. I think that this is one case that kind of shows how regulations can be used to mitigate risk, but the electric grid is, it's a somewhat unique infrastructure and industry. Other industries are structured in different ways, have different values, have different dynamics. Taking the regulations from NERC-CIP and applying them to other industries, it may or may not work. We don't really know. There needs to be greater kind of study of different industries if we want to start thinking more about the role of regulations for mitigating risk themselves. This type of thought process and this type of focus, regulations for risk, it's relevant to the electric grid and cybersecurity, but also to other critical infrastructures, and then society a little bit larger. If you look at some of the recent disasters we've suffered through. The 2010 Deepwater Horizon oil failure, that was in part caused by this drift from between the current regulations or the regulations that were in place and the changing technologies that were being implemented for deepwater drilling. Hurricane Maria that happened last year, it's also partly a regulatory challenge. There's a lot of informal housing construction in areas that maybe shouldn't be built on, and it meant that those houses weren't up to code, and it means that those people who lost their houses, they have a harder time receiving recovery funding. So regulations, they're central to risk management, and as of now, they really haven't been given the attention that they deserve as an object of research and as an object of thinking. I guess with that, I'm going to wrap it up. Are there any questions, comments, feedback, anything like that?
Hey, Aaron, this is Randy. I thought I'd ask one if you don't mind.
Sure.
It seems to me there was obviously a range of, I'm imagining that at least there are a range of behaviors with respect to the constituents that have to respond to the NERC-CIP standards. Do you know of any studies, or do you have any information regarding sort of metrics between those who fully embraced and sort of enthusiastically embraced the NERC-CIP standards, if there are such companies, and those who were on the opposite end of the spectrum, were very reluctant and took a minimalist approach in terms of their overall cyber security posture?
Yeah, that's a really that's an interesting question, and something that we looked at tangentially as part of our study. Some of the questions we asked were, what were the barriers and opportunities for implementing NERC-CIP to a high level, or implementing cybersecurity to a high level? We found a couple of things. One of them is the executive level this is where all of the decisions are being made. And if you want a good cyber practice, you better have executives on board who care about cybersecurity. And what we found, and what we heard, was that if there were executive level members with a cybersecurity background, they were much more likely to take cybersecurity seriously. But if that wasn't always possible, because cybersecurity is a new field, and executives often don't have that sort of background, and they don't come up through the ranks with that background. It's mainly engineers. So instead of that, another mechanism for getting utilities to embrace NERC-CIP and cybersecurity was having pretty strong communication lines between the executives and kind of the boots on the ground staff who were dealing with these issues. So clear reporting and clear discussions, and discussions and reporting in a way that's understandable. So not necessarily kind of technologically in the weeds, but high level kind of discussion about this is what this means when you invest in security in this sort of way. And there haven't been other studies that I'm aware of that have looked at organizations that have embraced versus haven't embraced NERC-CIP.
Okay. There is hang on, there's some questions in the chat window here. Let me see if I can get to them. So did the regulations, despite all the unanticipated effects, actually bring the system to an acceptable, if not ideal, level of security? And a follow-on, would more performance-based regulations provide better flexibility?
Nice. First question, acceptable, I think it depends on who you're talking to. Acceptable it's kind of a loaded normative word, and what's acceptable for one person may not be acceptable for another. And I heard this, that some were happy and some accepted the level of security that the standards brought, others weren't. I can say that they provided a certain level of security, and they did build that floor, but whether that's acceptable, that's a statement beyond my pay grade. The other question is, should the standards be a little bit more performance-based, or would that help with the regulations themselves? Performance-based standards, what that means, what those are standards where the standard would say you need to have security to a certain level, or you need to do a risk assessment, and then based on the results of your risk assessment, implement practices to mitigate risk. They're more flexible than the NERC-CIP standards, which are prescriptive. They say you need to be doing X, Y, and Z specifically to improve your security. There have been a lot of discussions in the NERC-CIP kind of arena about performance-based standards as an alternative. The benefits would be that you could perhaps substantially reduce your paperwork burden, and some of all of the financial resources you have to devote towards that paperwork, and you'll get standards that are or practices that are more specified to whatever that specific risk context is. So you wouldn't be treating a transformer out in the middle of nowhere the same as a transformer in the middle of a city. They'd be treated in different sorts of ways. So there are a lot of benefits of performance-based standards. One of the challenges is that they require a lot of trust, or more trust, between industry and regulators, because it leaves a little bit more discretion for industry to kind of decide what types of interventions they want to undertake and how they want to undertake them. So there's some costs too, and I'm not quite sure whether the electric sector has that level of trust for performance-based standards, but it's something that's discussed quite a bit in this context.
Great. Well, thank you, Aaron. We're running out of time, so I do want to thank you very much. Very interesting presentation. And I do want to let everyone know that our next webinar is on March 26th at 3 p.m. Central Time. And that talk will be Al Valdez from the University of Illinois here at Urbana-Champaign. And he'll be talking about his project that we undertook for FEMA, which looked at the causes, impacts, and mitigation of a long-term, wide-scale power outage in the Pacific Northwest. Very interesting project, very interesting geological region up there. I think you'll find it, fascinating. So I want to thank everyone for participating today. Thank you again, Aaron. Really appreciate your time and an excellent presentation. Thank you to all.
Thanks.
Cheers.
Thanks again, Randy. And if anyone has questions, my email is going out along with the slides, and this is based on a couple of papers that I'm happy to share with you. So just shoot me an email and I can pass on the papers. So thanks again for having me. Really
Thank you. Appreciate it. Bye-bye.